like, Mrs. Patton, I'm so
She
sorry.
would understand.
Yes.
So randomization in statistics and data collection, random sampling, to avoid bias. When the statistic for your sample over or under estimates the population's parameter, so that's randomization and data collection. In experiments, random assignment of subjects to treatments randomization allows us to equalize the effects of unknown or uncontrollable sources of variation among treatment groups. All right, so for the next one, randomly write down a number on the list provided. So don't do anything yet. Okay, wait till I tell you what we're going to do. Okay, you can write down those numbers, but don't write anything else yet. All right, so I have given you a list of the numbers 1, 2, 3, and 4. Okay? Randomly write down a number from the list. Okay? So what I want you to do is on your paper, don't say anything. I want you to choose a number and write it down. From 1, 2, 3, or 4.
Like underneath it or something?
Yeah, just leave a little bit of space underneath of it. Leave like one line of space underneath it. But just pick a number and write down your number. And I'm not going to do it because it'll make the numbers easier if I don't. Does everybody have their number? All right. Berkeley, what number did you choose?
3.
Maddie, what number did you choose?
4.
Sarah?
3.
Taylor?
3.
I knew y'all was gonna do it.
Melcher?
I'm not the one.
All right. So,
What if we all picked 3? That would be really funny.
I was gonna pick 3 and I was like, no.
out of our class, okay,
No one picked 2.
60% picked 3. 20% picked 4. 20% pick 1. and 0% pick 2. It's funny, last year when I did this, I had a class of 4 and nobody chose 1 or 2. They all chose either 3 or 4. I just thought it was funny.
I just picked the first number that came to my head.
I did too.
I probably would have picked 4 myself because that's like in my favorite number, so.
I
Number 1 is my favorite number, but I just like the sound of 3. Like, with this problem. Like, I looked at the numbers and I was like, 3 is the main one.
If I were to select a student at random, what does that mean to you?
Like without bias.
Well, like, what would it, if I said I was going to choose somebody at random, like, what would that look like?
If your eyes closed and you were
Like, 60, like,
Not
with the
covering your
numbers?
mouth,
With the
yeah.
numbers still? Like, in context with the numbers?
No, like, purely like, y'all are sitting in here and I say, I'm going to select one of you at random.
How many of there are there?
5.
So there's 20% you'll pick one of each of us? I don't know.
Okay, yeah. So basically, we don't know who's going to be chosen, right? Or y'all don't know who I'm going to choose. Okay, or I may not even know. I may pull your number out of a cup or something like that. Okay, and each of you have an equal chance of being picked. So we don't know.
Do you have an Apple Watch charger in here? I left my Apple Watch at school yesterday.
We don't know who would be chosen ahead of time. Each student has an equal chance of being selected. All right, so what can go wrong? Don't overstate cases. Okay, simulations show what might happen. Not what will happen. Okay, then model potential outcomes accurately. Don't imply. Outcomes are equally likely unless they are. Don't lump together outcomes. Model all potential outcomes. And then the last one, run enough trials. Don't make judgments. On a few number of trials. You should run at least 20 trials if you're doing it by hand. If you're doing it on a computer, you should run 100 trials.
That's a lot.
That doesn't necessarily mean you're doing a lot of work, because like your computer, you'll say like you'll pull up a random number generator and then tell it every time the number 4 comes across in each trial, tell me how many 4s are in there. You know what I mean? And like it'll do it for you.
Yeah.
And even when it says like do the 20 by hand, that really doesn't actually take that long.
No, we got front and back.
Yeah, I forgot to go over and make copies, and they kind of get mad if I use so much paper over here. So. I know, I'm just getting out of that because I'm going to have to go over and... Ah! What just happened?
That was scary.
I don't know what I did. Probably just scared Brooke. You're like, why are you screaming?
Is it nasty? It's really not. Those are fine. We're trying to make mine super neat in case Brooke like has trouble pulling up the video or can't focus long enough to like maybe she can like listen to it as long as she has it all written down or something. So I'm trying to make it super neat. I'm very proud of how my handwriting is looking.
I'm ready for bed.
Does that mean do I have to like the awards aren't coming this week, right? You guys aren't talking about it in chapel and telling us to come up there?
I don't think so.
Okay. I don't want to dress nice.
I'll try to give you a warning.
Thank you. That would be greatly appreciated.
I took really neat English notes yesterday, and I got up this morning and I was like, oh, I forgot to let you take a picture of my English notes. And then she goes, it's okay. This is Pat already sent me her nice typed out ones that she did herself. And I was like, I spent so much time trying to make sure they were very legible, and I didn't need to.
Mine looked so good. You know, that's what happens when like you actually do the work teachers tell you to do. They're lenient and they just give you stuff. But when you don't, they make you do it yourself. You don't deserve their grace.
We miss you, bro. Whenever you watch this video.
I love you, shorty.
All right. Explain why each of the following simulations fails to model the real situation properly. Use random numbers 2 through 12 to represent the sum of the faces when 2 dice are rolled.
Because 1 through 6 are what's on the dice.
Well, no, but it's two dice.
Yeah, but why does it start with 2?
Because you have 2 dice.
Which means
have-
you can
So the
never
smallest
get
number
one
you can
plus-
have is 2.
Is there a side of the dice that
Yes,
has like
actually
0?
there is. It's called the fourth side. Because you can't use random numbers. You have to use. Can you use random numbers? Does it not tell you how many trials you have to do or something?
No.
No, what's wrong with
So.
it? I don't know what's wrong with it.
So, how many possible ways are there for you to get the sum of 2?
One.
1. How many possible
Oh.
ways are there for you to get the sum of 12?
A
No,
lot.
1.
One.
well,
6
yeah,
and
that-
6
that
is.
was one.
more
Give me a
than
minute.
six.
There are other ones.
How
that-
about the number 7? How many possible ways can you get a 7?
More than 1. 2.
Okay, you can get 1 and
3?
6.
There's 3.
You can get 2 and 5,
that.
3 and 4. Okay, so there's more possibilities there. Okay, so if it was truly random, all outcomes would have to be equally likely.
Okay.
So in this case, the problem is that not all outcomes are equally likely. For example, a sum of 7 is more likely than a sum of 2.
I didn't even think of that. Maybe that's why I'm not thinking.
What? This is really confusing.
Is this the chapter of which like you guys had all of those games? Like out like the pig game, like the flip pig one that we played one day and
I can't remember if I did. This was this chapter or not. I don't remember off the top of my head. I don't think it's this. Well, it is. I guess sort of
Because it
this
was
one,
near around
but
the
it's this
Christmas time.
unit.
I thought it was
Yeah, it was
Friday.
around Christmas time, so that would be about right. Okay, so if you wanted to do this, like let's say you don't have dice in front of you, but you wanted to quickly run trials for this, I'm just going to tell you what you would have to push on your calculator to get that. Okay, you would hit math. Okay, then you would arrow over, okay, the options at the top. You'd be looking for the one that says PRB. Okay, meaning probability.
Oh, it's all caps.
And then you would scroll down a couple, I can't remember what number it is, but it would say RAND and then INT, okay, for random integer. Okay, and then it'll ask you for a couple things to go in there. Okay, well, let me rephrase. It's not going to ask you in the sense of how the other calculator functions have said, okay, like, tell me how, like how many numbers do you have? Okay, I have 20. How many of this? You're not answering questions to fill it in. You just have to know what it is. So basically, what we're going to put in here for our particular case is going to be random integer. Okay, I'm not going to actually run it, but I'll show you what it looks like. So the first number that you write is the smallest number that you could get. Okay, the second number, so you put a comma, so there's a comma button on your calculator above the 7, so if you're looking for it, that's where it is. Okay, 6 is the biggest number that could be on the dice. And then the last thing is how many are you taking at a time? So how many, like in this case, how many dice are you rolling at a time? You're rolling 2. Okay, so the last number is going to be 2.
Interessante.
Okay, so how many options do you have? The options you have are 1 through 6, and we're going to take 2 of them at a time. Okay, so I ran this one on my calculator. Or well, here. So it's the numbers 1 through 6, 2 at a time. Okay, so when I ran this, I got 1 and 5. And it'll look like this, okay, when it comes out and gives you that. So that would mean that my first sum was 6. Okay, one dice had a 1, one had a 5. So the total was 6. Okay. If I hit it again, I can run it again. The next time I got 1 and I got a 3. I just ran it one more time and I got a 2 and a 6, okay? So if I told you to run trials, I might tell you to run 20 trials. When you're done running those 20, you're going to add up the sum of each one and you would tell me what sum was the most common that you got. But Berkeley's won't be the same as mine. It won't be the same as Maddie's because your calculator is doing it
But we
randomly.
can't do this though.
Huh?
Like we technically can't do this problem.
Well, Yes, technically. I may ask you to do it, but it's not a good model of the real situation because it's not all equally likely. Does that make sense? Not that you can't do it, it's just not going to give you a completely accurate thing. If I ask you for the sum. Now, if I said how many times does the number 2 come up on a dice,
That would be different.
that would be different. Because then in that case, we would change this number 2 here to a 1. You have the options 1 through 6 taken one at a time, and you just keep hitting it until you've done 20 trials, and then you see how many of each number you got. So it's pretty cool how that works. Okay, but this is the calculator function, okay, that you need for that. So just be aware there. All right, part B. Use a random integer from 0 through 5 to represent the number of boys in a family of 5 children.
Does it have to do about not knowing the other children?
From the fact that it's from 0 to 5 and you're...
Yeah, so that's part of the problem. 0 through 5, there are not 5 different gender options, right? There's 2 gender options, so 0 through 5 doesn't make sense. And then,
Well, wouldn't it be the number of boys
Why?
in the
How
actual
could you have a
family?
0?
well,
Like, say if there was,
because you use 0 in place of a 10.
say there was like
Oh,
5
I
girls.
guess, like-
There would
Right.
be 0 boys. So
Right, because it's representing the number of boys in a family. So what we really should say, or how we should say the problem is that not all outcomes are equally likely. Okay, because there could be 0 boys, there could be 1 boy, 2 boy, 3 boy, 4 boys, 5 boys, right? You have all those different options, okay? And in reality, all boys is less likely than, let's say, 3 boys and 2 girls. Okay, right? Because obviously every time there's a 50-50 chance, okay? But now, there are families. I know a family of 5 that is all girls. I know a family of 6 that is all girls.
That would
I know a family that had 5 girls at one time.
Oh,
Okay?
my gosh.
So, it can happen, okay? So, if we were to do this, I would say, now you need to lay this out beforehand and decide, because you're not going to change this once you do it. But we would say boys are going to be represented by the number 1 and girls by 0. Okay? So on your calculator, follow the calculator steps, okay? Go to math. Go over to the probability and then arrow down its number 5, the random integer one. Okay? So what it's going to look like when you do it is going to be, hello, what is happening? Random integer, and we're going to put in 0 to 1, and we want them 5 at a time. Okay?
how do we? Oh, because there's 5 options.
Okay.
Okay, because we were going to do a family of 5. Okay, so when you hit that, okay, over here to the side, write out what you get at each option. So
Wow, that is
let's
so
run,
crazy.
let's do 5 trials just for the sake of space. Can we actually do problems where it wants us to specifically do this? We'll do it, but I'm just doing this to show you. Huh?
There's all boys in one of them. How exciting.
Okay, so on your paper, write whatever you got.
You're running 5.
Yep. Yeah, it'll just keep running it for you.
I got the same answer twice. Well, I mean, they're in different places, but like, I got the same.
So then we care about the number of boys. So beside each one, write how many boys you had.
I got the same thing. Like, not the same order, obviously, but like the same numbers.
Like every single time?
No, like with hers. 3 boys, 2 boys, 2 boys, 3 boys, 1 boy. So 2, 3 boys, and 2 boys, and 1 boy.
So with that, did anybody have any that they got no boys? Everybody always had at least one. Did anybody get all boys? Maddie and Taylor both got all boys. Okay. How about just one boy?
I got one.
Yeah.
How many times did you get one?
1.
Just one?
One.
Just one?
Once.
Just one? Okay. How about 2 boys?
2.
You 2 times,
Oh,
2
I got
times,
no
1
two.
I
time,
got them twice.
2 times. Okay. How about 3?
2.
2,
Twice.
2, 2,
Only
2.
once.
Yeah. And then did anybody get 4 boys?
I did. I got 2 4 boys.
Maddie.
Oh, wow.
Maddie's over here weird.
You got 1?
I know. I got no 2s and only 1 1.
I wonder if that's a prediction of your future, Maddie.
I
Okay, we obviously could do a lot more with this information in terms of figuring out percentages and stuff, but this is sufficient for now, okay, with that problem. But that way you just kind of get a little intro to how we're going to start running these trials and stuff like that. So then in 3, simulate a baseball player's performance at bat by letting 0 be an out, 1 be a single, 2 be a double, 3 be a triple, and 4 be a home run.
Well, each art is probable. Then not all outcomes are equally likely.
Mm-hmm. Yeah, so not all equally likely. Okay, with something like this one, we would need to know the probability of each outcome before simulating.
How do we do that in the map thing? Probability map random integer thing.
This one we're not going to, because you don't have enough information to be able to do this.
I see. Are you supposed to have example 4 on the bottom? Or you just move it all?
No, this is a page break. It's just the way that I screenshot it, because I basically had to screenshot the document so that I could like do this.
I was like, because you have a lot less space, and I thought I wrote small, so I had the space.
Oh, yeah, I don't know. It's weird. All right, we'll answer the first couple of. Well, we might have time to get through it. We'll see. Do any of y'all still need this page, or can I go to the next one?
No.
Okay. All right, so suppose and I'm not going to have, well, maybe I will. Suppose a basketball player has an 80% free throw success rate. How many shots might she be able to able to make in a row without missing?
You can tell us enough
You should
information.
do it out of 10 and then she'll probably make 8 of them.
So describe how you will simulate a component here.
The lowest would be 0.
Okay, so first, just a little bit here. Let me give a quick definition and then we'll do that. Okay, a component, because I don't think we had this definition anywhere. And I apparently can't spell. Component is the most basic event we are simulating. Okay, so now if you know anything about basketball, okay, you know that most of the time when you're shooting free throws, you're shooting 2, okay, but the easiest thing is to just count them all by 1. Okay, so we're going to make this the most basic case, saying that they're taking 1 shot at a time. So then, Berkeley, what were you saying we should use?
The minimum?
Well, you were trying to say something before.
Well, I said the minimum would be, I don't know. Well,
I'm going to simulate this on my calculator.
Oh, the minimum would be.
So what numbers am I using to simulate this with?
Single digits.
Okay, so I'm going to use random integers. Zero to 9. Now, if it said she had like a 75% free throw percentage, we would need to go to double digits. Okay. But since it's 80%, it works out nicely. We can use single digits. So we're going to classify in our case she makes 80%. So from 0 to 7, because that is 8 numbers, if that number comes up, if you see a 0 or all the way through a 7, it's a good shot, okay, that results in a make. If it's an 8 or a 9, which is the 20% that she misses, then it's a missed shot.
Do this on a calculator or like do it on
Yeah, we will in a second.
Is this the app thing that I didn't do yesterday? Program?
Not one of those.
I can quit.
All right, so describe how you will simulate a trial. Okay, basically, we're going to say that she's going to shoot shot after shot until she misses. Okay. I'm not going to do it with a random number table right now, but I will show you all how to do that. I just don't have one that's not all written on to be able to show that with. When we get down to the Run 20 trials, we'll just do it on our calculator for today. Okay. So I'm going to write here that we could look at a random number table. I need to find one that's blank because mine, for some reason, is written on, even though anyways. So use a random number table to find a series of numbers until we find an 8 or 9. Okay, for the time being, we're going to use our calculator.
So the minimum would be 0, maximum would be 9, and then what would we use as the inside? 20?
Huh?
For the random integer thing. Are we doing the thing that we just did with the probability thing on the calculator?
Oh, it'll be the numbers 0 through 9 with 1 shot per thing.
Are we going to the apps part to do it? Like we did, or is it the math thing?
No, we'll keep using the random integer thing. But first we need to describe the response variable, okay, which is to count the number of shots without missing. Okay, this is one that honestly probably would be easier with the random number table, which I'm kind of irritated that I don't have one here handy. But there is one in the back of your book. So basically, we're going to run trials. Okay, so I'm going to set it up.
So we just run it until we get 8 or 9.
Basically, hold on one second, I'll show you. Basically, this is, like I said, this is not going to be the best way to do this problem, but just for what we have in front of us right now, we're just going to use this. You're going to just keep clicking the button, and you need to count how many times you click it to get how many shots she takes before she misses. Okay? So in your calculator, you'd be putting here random integer 0, 9, 1. No, you do not count the miss.
Okay, so
It's how many she made before there was a miss.
okay.
So, like for example, on my first shot, I got a 6. Okay? So then I'm just going to hit enter again. Okay, I got a 0. And you don't have to write down what you're getting. Just keep track until you hit a 7 or an 8 or a 9.
Bro, my girl sucks. What's going on? Yo, she didn't even make the thing that time.
So.
Okay,
once
so
you
in
get
my
8 or
first
9
one, I had 6 makes before there was a miss.
Oh, but well, at least you can go back up and count.
Okay? So then we're going to do this. We're going to run it 20 times, okay?
What if they just literally missed one? We put 0 in a trial?
Mm-hmm.
You just keep pressing it 20 times. Well, not 20 times, but until you do that 20 times.
Yeah. Until you have put one in every single row. And then we're not going to have time to do what's beyond that, but just get through as many as you can now, and if we need to finish running them tomorrow, we can.
And you don't count the misses.
Correct.
She ain't very good. Oh, she got none in a row.
Last year, using the random number table, one of them there were 13 makes before a miss.
This girl literally just missed on the first try.
Mine had a really good middle section and then she just sucked again.
Oh, I just got 14. And then she missed again on the first try. Dang.
She's not very consistent, is she, Taylor?
Is yours consistent?
A lot of 2s, 3s, and 4s.
She's not proving.
Jeez.
28. It's kind of fun. I like that. I actually kind of like this section.
Yeah, this is a pretty easy section overall, because it's a lot of this.
Yeah.
It's fun. She's not, I guess she's not terrible. But, like, she actually has missed a lot on the first try with mine.
All right, so tomorrow we'll use those 20 to do the next part. And obviously, I expect all of ours are going to be different. I don't think anybody's is going to be exactly the same. So we'll do stuff with that, and then we'll talk about 5 that kind of ties in with that one as well.